If you consider yourself even an amateur astronomer, you should be familiar with the concept of Planet X. To this day, a lot of very well-respected astronomers continue to believe in the possibility of finding yet another world beyond Neptune, one that's simply too distant for us to spot currently. But I mean, come on, it's 2022. Well, actually, it's still November for me, but it'll probably be 2023 by the time this video actually comes out. But I mean, come on, it's 2023. We have telescopes that can see things 13 billion light years away. Surely we'd be able to spot something as big as a planet within our cosmic backyard. If there really was a Planet X, we'd have found it by now, right? Well, one of the big takeaways from my recent video on Pluto was that astronomy has been inextricably linked to technological progress. And we saw how the invention of telescopes in the 1700s is what made Uranus first visible to us. In the 1800s, calculus led us right to Neptune. In the 1900s, cameras captured 2 images revealing Pluto's movement. By the 2000s, we'd trained computers to analyze more of the night sky than was ever possible before, letting us start picking up on the many more ice balls beyond Pluto. But since then, there hasn't really been another significant leap forward in technology. It is only 2023 after all. Even the James Webb Space Telescope isn't really an advancement in technology so much as it is a perfection of numerous existing technologies, explaining why even after decades of searching, no sort of Planet X has been detected, which must mean one of 2 things. Either we have in fact already found everything there is to find, or we've once again reached our technological limits. If this ends up being the case, it'll only be with the arrival of new technologies that the possibility of observing any more distant objects becomes a reality, which is an incredibly exciting prospect, but also one that leaves me with a few questions. Exactly how much better does technology need to get? Could there really be more objects out there left to be discovered? And if so, will we in our lifetime ever find Planet X? The story of Planet X really begins with Planet 7, Uranus. To recap, in the 1840s, the French mathematician and friend of the channel Urbain Le Verrier calculated what its orbit must be based on its observed mass and distance from the sun. Except after comparing this prediction to what he observed, he noticed a discrepancy. Uranus was further out than expected, and Le Verrier postulated this could only have been caused by another planet even further out pulling on it. Plugging this hypothetical into his equations, Le Verrier arrived at where he suspected an 8th planet might be and sent its coordinates to his buddy Johann Galle at the Berlin Observatory. After less than an hour of searching, Galle spotted what Le Verrier had described: Neptune. Immediately, Le Verrier started analyzing its orbit and found it also to be out of place compared to his calculations. To anyone paying attention, this could only mean one thing: there must be another planet pulling on Neptune, and the search for a 9th planet, or what was dubbed Planet X, began. Nearly a century later, as a direct result of this idea, a large object beyond Neptune was found: Pluto. At the time of its discovery, many took this to mean the mystery of Planet X had finally been solved. The only problem is that as we learned more about Pluto's mass, it quickly became apparent that it was far, far too small to have perturbed Neptune's orbit, and if anything, it'd be Neptune perturbing Pluto. So you could say that while Planet 9 might have been found, Planet X had not. And so for the good part of the 20th century, astronomers from all over the world continued to search for the cause behind Neptune's funny orbit. This lasted all the way up to 1989, when NASA's Voyager 2 probe actually flew past the ice giant and took the most accurate measurements possible. In doing so, we realized our initial estimates of Neptune's mass were actually off by about 0.5%, which I know might not sound like a lot, but was actually the exact amount needed to explain the discrepancy between its orbit and our predictions. Almost overnight, the case for Planet X died, and people spent the next decade forgetting about the idea, until 2003, when a small group of scientists working through the Palomar Observatory in California made a remarkable discovery. Actually, several remarkable discoveries. If you'll remember, it was this team consisting primarily of Mike Brown and Chad Trujillo that's responsible for detecting numerous protoplanets beyond Pluto, like Eris, Haumea, Makemake, and so on. However, by 2003, they had only uncovered a handful of smaller, less significant objects like Sedna, Orcus, and Quaoar. While these were all too small to be considered proper planets, one of them, Sedna, was recognized as notable for a different reason. Here, take a look at this. These are the orbits of every planet in our solar system. Earth, Jupiter, Neptune, you see them all? Well, this is where Sedna was when we first discovered her. Pretty far away, right? At first glance, you might think, gee, wow, that sure is a big orbit Sedna's got. But here's the thing, that is not Sedna's orbit. If you're familiar with these sorts of things, you might know that more often than not, objects like Pluto can travel around the sun in more of an ellipse than a true circle. So you might look at Sedna and think, okay, well maybe it's just at the furthest extent of an irregular orbit like this. And you'd be, well, I guess you'd be right and wrong. You're right about Sedna having an eccentric orbit, only the boys in California got really lucky, about a 1 in 60 chance lucky, and captured it when it happened to be at its closest approach to the Earth in its 12,000 year long loop around the sun. I mean, I'm no expert in orbital mechanics, but something doesn't look right here. While some tried to explain this extreme orbit as the result of maybe like a rogue star passing by and yanking on it, or our sun capturing Sedna from another system, these explanations didn't hold up once we started finding more and more of these objects, all with similar if irregular orbits, confirming that Sedna wasn't an outlier, but rather part of a larger trend. A trend of objects being flung off a typical orbit by some mysterious force. The only explanation Brown, Trujillo, and thousands of more astronomers all around the world supported was that there must be another, far more massive object lurking on the outskirts of the solar system, causing this anomaly. Almost overnight, the search for Planet X began again. Trujillo published a paper where he argued this disturbance could be caused by an object anywhere between 2 to 15 Earth masses, orbiting anywhere between 200 to nearly 2,000 astronomical units away. Of course, its orbit would need to be equally elliptical, but in the opposite direction, sort of like how for every action there's an equal and opposite reaction, right? Seeing this, you might be tempted to think, well, then finding this planet should be easy. All we need to do is keep on the lookout for something along this pathway. But here's the problem. This represents only one of the many possible mass orbit combinations that could produce this anomaly. Because what we're trying to find is an object that could be anywhere between 2 to 15 Earth masses, this expands our search area from 1 dimension to 2. The sheer volume of sky this necessitates searching is in turn what has made locating any potential Planet X's out here exponentially harder than finding Neptune or Uranus. Well, that and just how utterly dim any planets out here would be thanks to how far away the sun is, leaving anything in this area virtually undetectable to all but the best of telescopes. Ultimately, it would appear that even today, technology continues to limit our ability to observe our surroundings. While this might feel like a disappointing conclusion to come to, I think it's actually the most exciting, as it means over the coming years and really throughout our lifetimes, technology will progress, and we will only become more and more capable of detecting any objects that may still elude us today. For once in history, the discoveries are ahead of us, not behind. Though I'll be honest, when trying to think of what kinds of technologies it would take to discover such a planet, I could only come up with 2 ideas. Either like an array of James Webb type telescopes positioned all around the sun, simultaneously capturing all 360 degrees of space and having computers or maybe even like AI sort through the bajillions of photos taken. Or we send a physical probe out there to look around, which honestly sounds about as likely as the first idea. While neither of these projects are particularly challenging, securing their funding and seeing them through would probably take a lifetime in its own. Heck, it'd take a probe 30 or 40 years just to get this far out, let alone find something. Of course, there is technically one other way we might be able to find a world like this without some kind of leap in technology, and that's by being patient. This field of study remains a remarkably new one and is being held up largely by just a few people. Thanks to astronomers like Mike Brown and Chad Trujillo, who continue searching pieces of the sky night after night, we will continue to learn more about this place we call our cosmic backyard, just perhaps not at the pace we would all like. Though our patience has already started to pay off, as more recently another oddity of the Kuiper belt was noted. By cataloging at least a few thousand of these objects, it's become clear that the belt abruptly thins out at around 48 astronomical units, forming a boundary known as the Kuiper cliff. Many see the only explanation behind this to be a body orbiting somewhere closer to this range, slowly grabbing up any smaller bits of ice or dust that come its way. However, this is where things get a little complicated. Models show this could only be done by a planet somewhere between Mars and Earth in terms of size, orbiting at most around 100 astronomical units. But that's weird, right? I mean, the solution to this first anomaly was a larger planet further away, whereas the solution to this second one is a smaller planet close enough to gobble up some Plutoids. This has opened the possibility of there being not only a planet X, but yeah, sure, a planet Y as well. But hold on, if you think that's crazy, this is only the beginning. Let's go back to Sedna for a second so I can explain why. You all remember how I said we got incredibly lucky here because it was at its closest to Earth right when we happened to be trying to see it? Well, Mike Brown, being a man of science, has rejected this idea of luck and instead embraced a new idea, one of probability. He argues the only reason we were able to find a Sedna-sized object on our first try, despite it being roughly a 1 in 60 chance, wasn't because we got lucky, but rather because there must be about 60 other Sedna-sized objects out there, all at different parts of their equally extended orbits, and the only one we've managed to find is the one that happens to be literally closest to us. Building on that, if there are 60 objects approximately 3/4 Pluto's mass, probability says there should be nearly 40 objects the size of Pluto out here, up to 10 that are twice its size, maybe 3 or 4 triple its size, and finally possibly one object bigger than even Mars, our planet Y, if you will. While this all might sound like some excessively optimistic conjecture, I should remind you that these estimates all come from the man who has discovered more of these objects than anyone else, and for all intents and purposes is the most knowledgeable person on the planet in this matter. If Mike Brown says there could be up to 40 Plutos waiting to be discovered, I'm willing to believe him. If Mike Brown says probability shows there might be one Mars-sized body here, I'm willing to believe him. If Mike Brown says the paths of some objects can only be explained with an even more massive one beyond this, I'm willing to believe him. Why? Because clearly this man and the people he works with understand how truly chaotic a natural system like a solar system can be. And because they work at the forefront of what we know, they also should understand better than anyone else what we don't know, if that makes sense. If it does and Mike Brown's numbers prove to be right, that means there might not only be a planet X causing sednoids to deflect and a planet Y eating up material along the outskirts of the belt, but also a whole nother alphabet's worth of undiscovered worlds that all fall somewhere between our definition of planet and not a planet. So to return to our question, will we ever find planet X? What does that even mean anymore? Knowing how many objects there could be out there, which one gets to be planet X? Spoiler alert, it doesn't matter. Once we find this object, this will become planet X. Once we find that one, these will become planet X, and so on and so forth until we've found every last pebble this side of the Oort cloud. Like this, we can see Planet X isn't an actual place, but like an idea, man. Asking will we ever find Planet X is like asking will tomorrow ever come. We've already found Planet X 3 or 4 or 100 times by now, depending on who you ask. And yes, with patience, we will continue finding new objects. What exactly will we find? Whatever's really there. Will anything truly satisfy our thirst for finding more? Probably not. But okay, let's do it. Let's put on our optimist hats and just for a moment say, okay, yeah, Mike and Chad are right. There really could be a 10 Earth mass object 200 AU away and a half Earth mass object 100 AU away. If so, what can we expect these places to be like? While it might seem like we know next to nothing about either of these worlds that may or may not even exist, that's not actually true. We know their potential masses and rough orbital parameters, which if you're a fan of this channel, you should know is about as much information as we tend to have on exoplanets. So we should be able to figure out at least a few basic characteristics on these potential places. Starting with the smaller of the two, a planet with half the mass of Earth will almost assuredly be a terrestrial world, composed mostly of rock and ice. Though given its position sweeping up stray Plutoids, I wouldn't be surprised if we found a lot more water ice here than even on Earth. If this is the case, we may come to find a planet with a thick icy crust sitting atop a huge mantle of molten ice, creating what could very possibly be the biggest ocean by volume in the entire solar system. An object this size, this far away from the sun, could even potentially hold on to a notable atmosphere. Finding a planet like this would be really exciting, as the only other ice world with an atmosphere we currently know of is Titan, which is what allows bodies of liquid methane or methanol to pool atop its ice crust. If similar conditions exist here, we may very well find a planet with two oceans, one of methanol at its surface and one of water beneath. Together, this points to the fact that if there really is a planet Y, it has the potential to be a very interesting, very unique place in our solar system. And in fact, everything we know so far points to this being the case. As for the larger, more distant world, we've learned from previous videos that exceeding 5 Earth masses plunges a planet's surface beneath so many gases that they become obscured and you cross the threshold into a gas planet. At an estimated 10 Earth masses, this would produce a world very similar to Neptune, though its specific color would depend on the precise mixture of gases and ices we'd see swirling around it from space. It's Neptune's primarily methane atmosphere that gives it its bluish color, though I've chosen to depict this world in this cold pink hue, not only to make it easier to tell apart, but also to remind us of the many different possibilities that exist here. And now that we know at least one or two things about these places, I'm sure all of you are wondering what sorts of names we can expect them to receive. And well, there's no real saying, as it's standard protocol for whoever actually discovers such an object to have the first say, which in all likelihood means it'll be Mike or Chad deciding what to call these rather than any of us. But even still, this raises an interesting question. In order for these objects to receive properly planetary names, like from Roman mythology and everything, they first need to be considered planets, which might actually be harder to convince people of than you think. I know, one of these could be the same size as the Earth, and the other would be even bigger, so of course they'd be planets, right? Well, if you remember the 3 criteria for planets the IAU established, you'll know they must have cleared their neighborhood, which is doubtful for either of these two objects, given how far away they are from the sun and all the stuff we've already found around them. That's right, even if there are new planetary type objects found here, there's going to be a new debate as to whether or not they are truly planets, and we may very well be forced to change our definitions once again. Of course, I think we all know the general public doesn't really care about rules like this, and chances are when or if these are discovered, every news outlet in the world will be calling them planets, and by extension, everyone learning about them for the first time ever will think of them as planets, no matter what the astro nerds say. Again, this just goes to show how arbitrary the term planet is. It means that even if these aren't actually considered planets, there will be so much backlash against this that the IAU will probably end up compromising and give them proper Roman names anyway. And if that's the case, then what types of names could we expect? Well, for such an icy yet active world like this, I figure a name like Boreas, the Roman god of the cold northern wind, would be most fitting. Though, okay, some of you might say there's already an asteroid named Boreas, which I guess is true. So maybe we'd have to look to his daughter Chione, the goddess of snow, which to tell the truth, I really like. If Chione does have an atmosphere and liquid bodies, this would support a full-blown methane cycle with evaporation, condensation, and yes, crystalline precipitation. So calling this planet Snow would be really fitting. As for the larger world lurking at the furthest reaches of our solar system, only one name really seems appropriate: Caelus. Now, I know what you're all thinking. Gee, Kalen, how'd you come to that conclusion? But trust me, Caelus was the Roman god of the sky, and primarily the night sky, whose Greek equivalent was actually Uranus, or Uranos. Yep, that's right, all the planets have Roman names except for Uranus, which is Greek, and actually means Caelus should have been what we called this planet, but the people who named it didn't really know that. Which is fine, I guess, because it leaves this important god's name open to be attributed to another planet, and yeah, is pretty similar to my name, which is pretty cool. Of course, before we start deciding on names, we need to actually find these objects if they even exist at all. Doing this, as we've learned, won't be easy, but if we're patient enough, I'm confident we will find planet X, Y, Z, and more. Of course, if being patient isn't really your thing, you can always head on over to Nebula, the premier streaming service built by all your favorite YouTubers, including me, where you can watch both my Astro and Atlas Pro videos days before they go up on YouTube, completely ad-free. And right now, you can gain access to Nebula 100% free when you sign up for today's sponsor, CuriosityStream. Here, you'll be able to continue learning about space with thousands of high-quality documentaries. Man, they're really making this easy for me. Literally, the first thing that came up when I opened their website was Stephen Hawking's favorite places, an awe-inspiring look at just about everything cool to see in space. This is the kind of stuff I aspire to make, so if you enjoy watching my videos, you'll definitely enjoy watching this. Using the link on screen or in the description, you can explore the entire CuriosityStream library for less than $15 a year and gain access to Nebula as a bonus. So if you'd like to help support the channel and continue learning about space, make sure to use the link and take advantage of this deal.